Imagine a business. They're using several different AI applications, maybe a chatbot for customer support, an AI that helps analyze market trends, and maybe a coding assistant for their software team. Now, each of these AI applications needs to pull data from different places. The chatbot might need customer details from a CRM, order history from their online store, maybe answers from a knowledge base. Market research AI needs access to industry reports, competitor info, their own internal sales data. And the coding assistant, it needs to work with code repos, project planning tools like Jira or Asana. Without a standard, each of those links, AI to CRM, AI to knowledge base, AI to code repo, and so on, requires a custom connection. That means a lot of specialized coding. It means needing to understand the unique way each system works and constant updates every time something changes on either end. This is known as the N by M integration problem. N different AI applications needing to talk to M different external systems, a tangled web of individual connections. Enter Model Context Protocols, or MCPs. Introduced by Anthropic in November 2024, MCPs offer a standardized way for AI models, particularly LLMs, to connect and share information with external tools and systems. Think of it as a universal adapter, a USB-C for AI. It allows AI models to interact with diverse digital environments, databases, APIs, file systems, and everyday productivity apps. MCP transforms that N by M nightmare into a simpler N plus M problem. Instead of countless custom links, tool creators build MCP servers, one for each system they want to make accessible via MCP. To fully understand MCPs, we need to understand a few key terminologies. The host is the main application where the AI lives and works, like an AI coding tool or a chatbot. It manages MCP clients, handles security, and gathers information for the AI. Inside the host is the client, specifically an MCP client. This is like a dedicated messenger that establishes a continuous connection with an MCP server. It handles the communication details, manages data subscriptions, and ensures security boundaries. The server, or MCP server, is what makes external data, tools, and capabilities available through MCP. It acts as a translator or wrapper around existing functions of something like a database, an API like GitHub or Slack, or file management. The key is, it speaks the MCP language. Now, the things AI can interact with. Tools are the actions the AI can take. These are executable functions an MCP server makes available, things like sending an email, querying a database, or creating a project task. User consent is usually required for these actions. Resources are different. They are read-only sources of information providing context, think file text, dial trace, records, or API call information. So tools are for doing and resources are for knowing. There are also prompts, or prompt templates, which are reusable, pre-written messages or instructions a server can offer to guide users or the AI in specific tasks. And finally, sampling is a feature where an MCP server can ask the client, and thus the AI model, to generate text or complete an idea, like drafting a commit message. This lets the server leverage the AI's language abilities, but it requires explicit user consent. So how does MCP work in practice? Communication begins with an initialization phase, essentially a handshake. The client sends an initial request stating its MCP version and what it can do. The server responds with its compatible version and its own capabilities, like the tools and resources it offers. The client then sends an initialized notification to confirm, setting the ground rules. After this initialization, they exchange messages using a standard format. These messages include requests, where one side asks the other for something and expects a reply. Examples are a client asking for tools, getting a resource, or calling a tool, or a server sending a sampling request. Then there are results, which are the successful replies with the requested information or confirmation. If something goes wrong, an error message is sent. Consider an example. A coding assistant, which is the host, wants to create a new Git branch using an MCP server for Git. The MCP client in the coding tool connects and initializes with the Git MCP server. That's the handshake. The client might then ask for available tools. The server responds, listing a tool like Git create branch. When the AI decides to create a branch, the client sends a request to call that tool, providing the tool name and the new branch name. The Git server runs the command, and if successful, sends a result back. The client then informs the host AI. Ending the connection is usually a clean shutdown, initiated by either side. MCP adoption is impressive across various areas. In software development and coding assistance, tools use MCP to give AI assistants access to project files and Git history in tools like Zed, Cursor, and VS Code. For enterprise assistance and knowledge management, companies are connecting internal AI to proprietary data like wikis and HR systems. Employees can ask a single AI for answers synthesized from these internal systems. We're also seeing it in lifecycle marketing automation, connecting AI to different marketing platforms. Potential uses include financial services, securely connecting AI to banking systems for things like fraud detection, and healthcare, bridging AI with patient records for clinical support. The list of MCP servers is growing fast in areas like customer support, personal finance, and desktop automation. Leading AI research labs and companies have embraced MCP. Anthropic, its originator, heavily utilizes it within its Claude ecosystem, particularly Claude Desktop. OpenAI has announced support for MCP, integrating it into ChatGPT and its agents SDK. Microsoft is another significant adopter, incorporating MCP support into Copilot Studio and contributing a C# SDK for the .NET ecosystem. The Model Context Protocol is positioned as a potential universal standard for AI integration. If you want to explore further, check out the provided links to the MCP specification and resource examples in the video description. And please subscribe for similar AI-related videos.